For many years, mankind has wondered about the existence of life on other planets in the universe. It is impossible to look up at the night sky and not feel that there must be another life form out there somewhere. We have not been able to identify any Earth-like planets, but we have found other terrestrial bodies with Earth-like characteristics. Based on our current understanding of the conditions for life, these locations have been identified as the most likely places for life to be found. One of these is Europa, an icy moon of Jupiter. Europa is the sixth largest moon in our solar system, and the sixth closest to Jupiter. It is 485 million miles from the Sun, with an average surface temperature of negative 160 degrees Celsius. The moon receives a large amount of radiation due to magnification of solar winds by the enormous mass of Jupiter. These high-energy particles collide with the surface and liberate oxygen, creating Europa's atmosphere. It has an iron core and a rocky mantle, as well as liquid oceans that lie beneath the icy crust. Similar to Earth, there is evidence of plate tectonics, which have caused the thick ice of the crust to break apart and float into new locations along the surface of Europa, much like that of Pangaea. The activity of the plates shifting has indicated a likely presence of hydrothermal vents within Europa's oceans. Hydrothermal vents, should they exist, would bring the rocky core in contact with the subsurface oceans, and thus be able to provide the necessary chemical exchange that would allow for life to be sustained on Europa. Europa is the only planet besides Earth which has tidal forces. Due to the gravity of Jupiter, Europa experiences tidal flexing. This heats the inner core, creating the subsurface oceans beneath the icy crust. This heating, along with the possible presence of hydrothermal vents, makes Europa's subsurface oceans the #1 candidate for life. NASA has already planned a mission to Europa, which will launch in the year 2020. It is proposed that the spacecraft will carry a thermal emission imaging system, high-resolution camera, and an ice-penetrating radar to satisfy the aim of collecting general information about the moon, such as possible warm water surface volcanoes, subsurface lakes, and general mapping of the surface. It also aims to satisfy some specific aims, such as determining the surface ice shell thickness, as well as the depth and salinity of the ocean. We propose to further the interests of NASA by adding a secondary probe to the orbiter that can be launched from orbit and land on the icy surface of Europa. After identification of surface vents through the instrumentation on the orbital module, the secondary probe will then be launched through the plume and land near the surface vent. We believe that, if equipped with a mass spectrometer, surface dust analyzer, and a more advanced mapping imaging spectrometer, that we will be able to specifically determine the composition of both the atmosphere and the deep ocean in relation to distribution of organics, salts, and other minerals. This two-part probe will not only complete every aspect of the proposed NASA mission, it will vastly increase the data collected and greatly add to our ability to determine if life can be or is currently present on Europa.